Good morning, everybody. I hope all of you are doing great. Good morning, everybody. Welcome to Unacademy's YouTube channel. My name is Hafsa Malik, and I am your educator for psychology on Unacademy. I hope all of you are doing great. I can't see ma'am. I can't see ma'am. Oh my god, who has been pranking on all of the kids? Okay, all right. Okay. Yes, Shabina, regular होती हैं. All right, guys. Good morning. Good morning. Good morning. Yeah, Prince is pranking everybody. That's okay. That's okay. All right. Good morning, everybody. I hope all of you are doing great. It's not a biological basis of behavior and it's not action potential. I'm sorry for this. Today is going to be vision and audition. What does that mean and what are we going to discuss? See, the thing is, I'm sorry again, Marvel movie reference, but does anybody know vision? Not this vision. We are going to discuss this vision and we're going to talk about auditory perception. Welcome to my class. It's very good to see all of you. This is a very important topic and we're going to discuss it today. Class का जो title है वही हम discuss करेंगे. Please don't get fooled by this, okay? We're going to talk about auditory and visual perception. I hope all of you have had a great day. I hope all of you had a good Holi. Yeah, okay. All right, let's get started then. Let's get started. This is a very important part of your syllabus. And let's talk about what else should we talk about? What to do if you want to join the classes. Why is this not working anymore? Okay. Okay, all right, it's working. ठीक है. So if you do want to join my classes, I teach for NTA UGC NET. मैं GATE के लिए भी पढ़ाती हूँ. I teach clinical psychology as well. Everything under one roof. Like I've introduced myself already. My name is Hafsa Malik. So you can use my code Hafsa Live. आप मेरा code Hafsa Live use कर सकते हैं to get access to my free classes. Who doesn't want access to free classes? And आप यही code use कर सकते हो to basically get 10% off on your subscription. जो भी subscription आप ले रहे हो, you can get a 10% off if you use my code Hafsa Live. Okay, all right, ठीक है. This is my complete course which is going on. You will find it on Unacademy. Classes on YouTube happen every Saturday 11 a.m. My norms for you today are that please take a look, but look properly, in the sense pay a lot of attention because these topics are considered quite complex and it will be best if you can stay focused throughout the class. Class is going to be of 90 minutes. Probably, and then you will have to stay here and pay attention and respond and participate throughout the 90 minutes. Okay, so I would love for you to participate as well. And then lastly, what is this? This is listen and pay attention. Alright, okay, chaliye. Now, first of all, we will talk about the visual system, and for that, it is very important for us to understand the eye. है ना? We have done the structure of the eye, but I just want to see if you guys remember. मैं आपको पूछूंगी और आप मुझे बताएंगे. तो visual system understand करने से पहले, visual perception, color perception understand करने से पहले, it's very important that you understand and that I know that you understood the structure of the eye. Right? Okay, fine. Can we do that? Can we do that? I think the comments are reaching me very slow. Okay, ठीक है, fine. Then let's get started. Do we say that the outer part is the cornea? And then the cornea is responsible for the amount of light that goes into the eye? If I were to say that, would that be correct? If I say that the amount of light that enters the eye is controlled by the cornea? Nobody's saying anything? Or am I just not getting the comments? Oh, okay. No, it will not be the cornea. The amount of light controlled by the eye is controlled by the iris, which is the colored part of your eye. ये देखिए, cornea से light आती है, which bends over here. Then it's going through the pupil. Okay, pupil is the dark part of the eye, which is generally black, right? And then you have the colorful part of your eye, या the colored part of your eye. Indians में ज़्यादातर brown होता है. Brown is a very common color. In fact, any country, most of the iris generally in people will be brown. Okay, Not brown, but brown. All right. So for us also, that iris is what controls the amount of light that enters the eye. ठीक है, ये iris जो है यही कंट्रोल करता है कि कितनी लाइट हमारी आई के अंदर जाएगी. And then from here we go through a transparent lens where again the light which has been bent earlier at the cornea again will bend, right? So it depends on where the light basically bends, at what angle it bends, and therefore we will understand what angle it's going to be projected at. है ना? Now all of these images we know are going to be projected at the retina. Can I say that? ये retina पे ही जाएंगी images? जाएंगी तो, है ना? Now the retina has one very good spot known as the yellow spot or the fovea, where what happens basically is, what happens is that all the cone cells, photoreceptors होते हैं, cones and rods, all of the cone cells are concentrated here. And then across the peripheries of the retina, we also have rod cells, which are basically found here. है ना? ये दोनों photoreceptors हैं. We already know that. Why am I not receiving any of the new comments? Let me refresh, guys. Let me refresh. I'll try to access the link again. Okay, chalo, finally I can see. Hanji. So in the peripheries we have rod cells, right? And this is, can I say this is perception or can I say this is only sensation? इसको हम perception कहेंगे या सिर्फ sensation कहेंगे? So towards the peripheries it is only rod cells, whereas towards the fovea it is only cone cells. Yes? Okay, I can say that. Absolutely. ठीक है, fine. Now let's look at what light rays we are able to perceive. हमें पता है vision के process में what we actually do is, it's the light waves that are transduced, physical energy, light energy, which is the physical energy we take in, which is transduced to electrochemical energy. Can I say that? I transduce it to electrical and chemical energy, है ना? अब जो light rays हम understand करते हैं, ये कैसे हम understand करते हैं? What light rays do we take in is very important for us to understand. ठीक है? So let's try to see our visible spectrum. जो light rays हमारे visual field में आती हैं और जो light rays हम visually perceive कर पाते हैं या visually ले पाते हैं अंदर, which we are able to actually understand. See, infrared is beyond the red, which we are not visibly going to be able to see, and then ultraviolet is the lower end of your spectrum जो हमारे लिए visible नहीं होती हैं light rays. Okay, all right, wonderful. Now let's see. Around 360 or 380 is basically where our visible spectrum starts. And here around 760 or 780 is where it stops. ठीक है? ये wavelengths होती हैं और ये nanometers में measure की जाती है. NM, nanometer. Okay, all right. So it goes from the lower end, which is violet. आपको पता है we have this mnemonic called Vibgyor या Vibgyor. Vibgyor या Vibgyor is what we say. V, I, not B, V will come here. G, Y, O, and R. Or O might come a little here as well. ठीक है? Vibgyor basically means that we have all of the colors of the visible spectrum. ये हमारे सारे colors हैं visible spectrum के. और ये बिल्कुल एक, can I say, they're in a certain, क्या कहते हैं इसको? They're in a certain sequence, can I say? If you check from here to here, sequence बनती है ना इनकी? बनती तो है. Absolutely. Okay, all right. Then let's try to understand that this Vibgyor, how does it actually correspond to our photoreceptors? क्या हम ये कह सकते हैं कि इन colors की कोई हमारे photoreceptors के साथ relation है? Can I say that this VIB corresponds to a certain kind of cone? See now, guys. Now that we are talking about colors, will I relate them to rod cells as photoreceptors or will I relate them to cones as photoreceptors? Rods or cones will I relate them to? I will relate them to the cone cells. इनको cone cells के साथ हम relate करेंगे, rod cells के साथ नहीं. So all of these are the responsibility of cone cells. Okay, so we'll try to understand what cone cells are responsible for understanding what color. तो जो आपके violet, indigo, blue हैं, these are responsible or these are given to or projected at small wavelength cones. Small wavelength cones. which generally will understand the color blue overall. Then we have medium wavelength cones. Medium wavelength cones, which will understand yellow and green, mostly green though. Medium wavelength cones. Very very good. And then we have large wavelength cones. मतलब यहाँ पे wavelength तो बड़ी है ना. It is what? It's over 600, 580 nanometers. Yeah, it's over 600 nanometers. So you see that the wavelength of these colors is larger, and these are taken in by the large wavelength cones. Okay, can we actually distribute these to colors? Can we distribute these particular wavelengths to particular colors, which can again be represented by cones? So can you tell me three colors, three primary colors that we are getting here? क्या हम तीन प्राइमरी कलर्स को यहाँ पे ले सकते हैं जो करेस्पॉन्ड करते हैं कौन सेल से? So can I maybe say that the small wavelength cones are basically representing blue color? That will make understanding the theories of color vision and theories of color perception much easier. The medium wavelength cones are represented by green color and they are taking in green color, and therefore color blindness understand करने में भी help होगी कि देखो ये कौन काम नहीं कर रहा है तो ये color blindness हो रही है, right? Deuteranopia, protanopia, tritanopia. Okay, and lastly the large wavelength cones are represented by the color red. ठीक है, और यही कलर्स विद along with black and white are all of the colors, and yellow are all of the colors that we talk about in your color perception theories. Okay, all right. Anybody has a doubt so far? Please ask. अगर आपको कोई भी डाउट है अभी तक प्लीज पूछिए. Red, green and blue. Absolutely. Please ask if there are any doubts. No doubts only? No doubts? All right. Okay, then let's move. So first we will move on to young Helmholtz trichromatic theory of vision. ठीक है, पहली बात हम करेंगे trichromatic theory of vision की. What is this trichromatic theory of vision? Can I say that basically just like we saw earlier, we have the three colors, वही तीन colors हैं, red, blue and green. Right, so can I say this is the large wavelength cones and this is taken care of by the small wavelength cones and this is taken care of by the medium wavelength cones. Okay, so the Helmholtz theory of color vision basically says, okay, one moment. So here Helmholtz actually says that the retina has three types of color receptors. पता तो है हमें, right? And each one of them is most receptive to a certain color. So depending on what color the receptor is most receptive to, most likely to understand. So I'll answer Prince's question here. Okay, do you have to learn wavelengths? Yes, you do. 360 to 380 to 760, something like that. You just have to know so much. बस वो आपको याद रखना है. See, our eyes most easily recognize violet. You'll see people who even have tendency towards being dichromats. A lot of times somehow they understand blue, but they may not understand the color violet. ठीक है, उसके लिए थोड़ी कोन्स की प्रोफिशिएंसी ज्यादा होनी चाहिए वायलेट अंडरस्टैंड करने के लिए. Because see, it's right above the ultraviolet rays. So blue is understood better, blue is perceived better, and blue is therefore considered a primary color. All right, great, wonderful. Now we've already done the background work for this. It's going to be very easy for us to understand how colors are created here. देखिए, color perception additive होता है, subtractive नहीं होता है. आप यहाँ पे अगर देखेंगे, I'll repeat this in English also. Color perception here, according to young Helmholtz, is additive and not subtractive. Can I basically say here that because green and yellow are added, I am able to perceive a yellow here, blue and yellow are added, I'm able to perceive green. Can I say that? Or here when you see a little bit of red and a little bit of yellow combined, I'm able to perceive orange here. And because the yellow is getting intensified, additive, I'm able to perceive orange here. So can I say that color is additive? क्या हम कह सकते हैं ये कलर परसेप्शन जो यहाँ पे है एडिटिव है? So we perceive not what is absorbed by the eyes but what is reflected by our cones. ठीक है, तो हम कलर कौन सा परसीव करते हैं और कैसे परसीव करते हैं? We need to understand. So let's talk about that here. See, what do we perceive? So we perceive actually what is reflected. What is reflected? तो अगर मैं आपको कहूं कि all of the colors till orange are absorbed, then what is reflected? Red is being reflected right now. What color are you seeing? What are you going to tell me? If I tell you कि बाकी सारे colors absorb किए हैं लेकिन red आपकी eyes reflect कर रही हैं, object जो color reflect कर रहा है वो red है, तो what color are you actually seeing? Are you seeing orange or are you seeing red? Tell me now. Okay, waiting for answers from others also. What do you see? If your eyes are reflecting red but are absorbing orange and yellow and green and blue and violet. What are you seeing? What color are you seeing? You're seeing red. Very, very good. Very, very good. So according to young Helmholtz theory, we have three distinct cones. And we do, yes, such hai. This is proven to be true. So in these three cones, they are responsive maximally to three different types of color, which are our primary colors, red, green and blue. And इन्हीं का addition करके हम सारे colors को perceive करते हैं. Can we say that different colors are simply an addition of these colors? They are. And what we need to remember here is, this also we have done already, keep particular wavelengths are most responded by particular cone cells. And then we need to understand that the color we see is the wavelength that is reflected. So if I tell you none of the colors is, आपके visible spectrum के कोई भी colors में से कोई भी absorb नहीं हुआ है, what color will you see? If none of the colors which is there in the wavelength, in the visible spectrum is absorbed, what color will you see? Will you see black? Will you see black? I'm waiting for all of you to answer. What color do you think you will see when you don't absorb any of the colors from the visible spectrum? When nothing is absorbed, we see white. When everything is absorbed, we see black. Okay? All right. When nothing is absorbed, what do we see? We see white. Because all of the light wavelengths are simply reflected back. Okay, so what we see is white. And when everything is absorbed, आप यहाँ पे देखो, when you look at the wavelengths, what is beyond this is brown here. Here actually what you have is really dark red, which is almost brown. ठीक है, तो जितना आप सब चीजें absorb करोगे, the combination of all of the colors is nothing but black. So when all of the wavelengths are absorbed, all right, okay, clear so far with me so far? ठीक है. Now let's move on to another theory. I feel like the trichromatic theory is quite easy for people to understand. ठीक है. But it is the other theory which is Ewald Hering's theory where people have a lot of difficulty in understanding. मेरे ख्याल से जो previous theory है वो सब समझते हैं. Color is additive, color is corresponding to your three types of cones, and then when those three primary colors are added, and depending on what we basically absorb and what we reflect, we perceive color. Now, Ewald Hering basically said that we have opposing pairs of colors that we perceive. यहाँ पे बात हो रही है opponent process क्या है? ये ऐसा हो रहा है कि colors के जो हैं pairs हैं, ठीक है? He created, now rather than three particular colors, he chose three pairs of colors, which when one is perceived, the other is inhibited. ये आपको याद रखना है, यहाँ पे जब एक color perceive हो जाता है, दूसरा inhibit हो जाता है. And then here you see these three pairs not only included red, green and blue, but also included red and green, blue and yellow, and black and white. Were the three different or three distinct pairs. Okay, alright, fine, fine, theek hai. Now opponent process theory basically says that the perception of one color will inhibit the perception of another. And this also explains the phenomenon of after images. क्या आपने after images कभी देखी हैं? If you see anybody calling this hallucination, please report them. उनको report करो. Alright, now you will understand what I'm trying to say later. Let's say for a long time I create a red dot here. ठीक है? I'm creating a red dot here. Now stare at it with all of your capacity. जो भी आपकी visual capacity है इस red dot की तरफ आप stare करो. With full focus, with full concentration. ठीक है? For a few seconds. Stare at it, intensely stare at it. The moment you look away, what color do you see? The moment you look away, what color do you see? You should ideally see, you should see green. If you're not seeing green, then I don't know what's happening. Alright, and that is just because of the opposing mechanisms of certain colors being perceived in our brain. हमारे दिमाग में जैसे colors understand होते हैं वो pairs में होते हैं. This theory was known to be true. Okay, just as young Helmholtz theory was also known to be true, that cones are of three types and they basically whatever information is taken in by only these three cones is simply added and later we perceive based on that. Okay, alright. हाँ, green only, no magic, just the opponent process theory. Guys, हाँ, please report all such accounts. Anyway, alright, ठीक है. तो यहाँ पे ये कहना है इनका that the moment we perceive white, we cannot perceive black at the same time. In the sense कि जब आप एक area में white देखते हैं वहाँ black same नहीं हो सकता ना. There is no whitish black. Don't say grey. Grey is not whitish black. Okay, alright. Are you understanding? Have you ever seen a reddish green? क्या आपने कभी reddish green देखा है? So the three opposite pairs are black and white, red and green, blue and yellow. क्या आपने कभी bluish yellow देखा है? नहीं, वो green हो जाएगा. वो bluish yellow नहीं रहेगा और red and green combine करके आपको brown मिलेगा. There's going to be no reddish green. Okay. Alright. Correct, Devyani. Correct. ठीक है? Okay. So when you basically see there's not going to be any reddish green. So that is what this theory is all about. It says कि हमारे पास opposing pairs हैं and जो colors हम perceive करते हैं we generally do it in where if one of these colors is being perceived the other is being inhibited. ठीक है? Other is being inhibited at the same time. तभी कोई reddish green नहीं होता, bluish yellow नहीं होता, blackish white नहीं होता. And this theory also explains the concept of after images. If you stare too long at a black dot, you will see white immediately after. ठीक है? Alright. Prince is in a nice mood. That is which is good to see. Alright, okay. And then if you stare at something blue for a long period of time, you're highly likely to see a yellow dot after that. ठीक है, चलिए. Fine. ठीक है. Okay, alright, called the lateral geniculate nucleus. Now here opponent process theory has also proved the connection of the lateral geniculate nucleus serving as a pathway. For what? We know very clearly that we have two systems, the parvocellular and the magnocellular system. Yes? Yes. Now which pathway passes through this area of the lateral geniculate nucleus where color vision is taken care of? Which pathway passes through? Which pathway are we talking about over here which cares about cone related vision, color related vision, detailed vision, slow vision? What pathway are we talking about? Which pathway is going to pass here through the lateral geniculate nucleus? बताइए. Yes ma'am, बताइए. कौन सा pathway? Okay, it is going to be the parvocellular system. It's going to be the parvocellular system. Okay, alright, great. Yes. Magno, you'll get scoldings if you keep saying, okay. Alright, it's the parvocellular system. Absolutely, it is the parvocellular system. Chaliye, let's go. let's go and let's try to understand now why we see differently in light and in darkness and who's responsible for it. This is really interesting. This is really fascinating. We will do depth perception, 3D, 2D and all of that in our perception chapter, Gestalt portion as well. So right now we'll talk about why we perceive and why we see differently during the day and during the night. And this depends on the two systems of vision. ठीक है? There's this theory of vision which is called the duplicity theory of vision. ठीक है? यहाँ पे क्या हमने ये डिस्कस किया है कि photopic vision is the one that is supported by the cones and scotopic vision is the vision supported by the rod cells. क्या हमने ये डिस्कस किया है? Have we discussed this in the past? We have discussed this in the past. Yes, okay, absolutely. You see, duplicity means that within the same eyes, we have two types of visual systems. And when the perception of all of this information takes place, then also we have two different systems of vision. One that works best during the day and one that works best during the night. है ना? ऐसा होता है कि एक सिस्टम दोनों में से दिन में बहुत अच्छा काम करता है और जो दूसरा है वर्क्स बेस्ट इन द नाइट. वी नो स्कोटोपिक विजन इज आल्सो नोन एज नाइट विजन या लो लाइट विजन. तो हम कह सकते हैं कि लाइट इंटेंसिटी कैसी होती है? लाइट इंटेंसिटी लो होती है. लो लाइट इंटेंसिटी. Okay, then can I say that I need high sensitivity vision here? Can I say I need high sensitivity vision here? Rods are highly sensitive to light. Remember the magnocellular system, it is responsible for understanding even the smallest changes in brightness. Brightness में सबसे छोटी changes भी ये perceive करेगा. Right? Highly sensitive to light. Remember guys, always that rod cells are more sensitive to light than cone cells. Cone cells are more sensitive to the different colors which are presented or projected by the different wavelengths. तो photopic system जो आपका है ये high intensity light में काम करेगा, which is during bright light and daytime or any light in your room, that also works. Here we will see high light intensity. Here we see high light intensity and here we will see lower light sensitivity क्योंकि cones को ज़्यादा effort डालने की ज़रूरत नहीं है. They are as it is being able to perceive colors with very good clarity, high visual acuity. We don't have to worry about whether the cones are able to understand the colors or not, right? So here we don't need that great sensitivity. Are they sensitive to color? Of course they are, but are they as sensitive as the rod cells? They are not as sensitive as the rod cells. Not as sensitive as rod cells. Okay, once we have established that, only then we can understand the duplicity theory of vision. Now we already have done the visual pathway and all of that. First, we will try to understand what exactly happens in light adaptation and what exactly happens in dark adaptation. ठीक है? तो light adaptation में हम क्या कर रहे हैं? अभी moving from a dark place to a light place. Can I say that? Light adaptation. Or am I going from a bright place to a dark place? Light adaptation में. Light adaptation is occurring when I'm going from a dark place into a bright space. ठीक है? जब हम डार्क प्लेस से ब्राइट प्लेस में चले जाते हैं, दिस इज नोन एज लाइट अडेप्टेशन. नाउ लेट अस से दैट यू वर इन अ थिएटर एंड यू वर वाचिंग अ मूवी. You were in a theater and you were watching a movie and it was nice and dark and your rod cells were highly accustomed to it. Your rod cells were having the time of their life and suddenly when you went out and you're like, oh my god, what is this so much light? How can my eyes tolerate it? है ना? Absolutely. तो होता क्या है? Now tell me, you will not have any cone cells which are ready to basically take in all of this light. What color will you see? कौन सेल्स नहीं है सरफेस पे, रॉड सेल्स हैं. आप मुझे बताइए कौन सा कलर आप देखेंगे? ब्लैक देखेंगे या व्हाइट देखेंगे? You are bound to see the color white because your cones are not functioning at the time, and therefore everything that comes onto your eyes is simply reflected back and we absorb nothing. Therefore, the color that we see is white. Very, very good, guys. Very, very good. Absolutely. Now let's try to understand why this happens, how this happens. Rod cells जो हैं अभी रेटिना पे उनका क्या हो रहा है. See now what is going to happen to these rod cells which were highly functional inside the theater. Rod cells ही थी ना functional inside the theater. Now we are bleaching them. Okay, इनको bleach किया जा रहा है. The light, when they are exposed to the light, they get bleached. Then can I say that they are getting destroyed? ये पिगमेंट है, पिगमेंट को आप ब्लीच करेंगे वो डिस्ट्रॉय हो रहा है या नहीं हो रहा है. Rod cells are made up or they contain a pigment called rhodopsin where vitamin A plays a huge role. Rhodopsin है ना. ओके, तभी जिसको विटामिन ए डेफिशिएंसी जिसको होती है we call them night blind also. They say they have night blindness. Retinol and all of that is present here. हाँ जी, चलिए. ओके, हैलोजन वाला व्हाइट मैम, हैलोजन वाला व्हाइट. हाँ क्या, हाँ. Okay, all right. So rod cells get bleached, they get destroyed. So it takes some time for the cone cells to come to the front, and therefore some time is taken in light adaptation. Okay, all right. Below normal for 5 to 10 minutes. ये bleach को basically takes time for the bleach to destroy the rhodopsin, and then cone cells from they come to the center front and they are basically able to take all of the information. Remember guys, cone cells do not get destroyed here. Cone cells destroy नहीं होती हैं, rod cells destroy होती हैं. Okay, therefore it takes around 5 to 10 minutes to see colors properly. I'm not saying to see, barely हम देख पाएंगे, but for it to have highest visual acuity it will take around 5 to 10 minutes from when we come from a dark place into a light, a space filled with light basically. Alright, ठीक है, fine, okay. Now we will try to understand here what's happening. तो indoor light भी ये light vision होगा, high intensity of light vision होगा. Absolutely. So here we are not just talking about outdoor light or when you go out into the real world. We are talking about outside as your home also. Whenever the lights are on, it is basically light vision, and it is light adaptation if you go from a dark place where there was dim light to a room where there is bright light as well. It's all the same. ठीक है? Okay. All right. Now let's try to summarize light adaptation. Okay. Now that we have read it here, let's try to summarize light adaptation. Okay. Can I say that यहाँ पे हम rod cells से cone cells पे shift कर रहे हैं? Can I say that we are moving from scotopic to photopic vision? Moving from scotopic to photopic vision? Okay. All right. We are moving from low light intensity to high light intensity. Can I say that? Okay. I'm moving from a low light intensity to a high light intensity. What is actually happening? What's getting destroyed? जब भी हम light की तरफ आ रहे हैं, first when we come from a dark to a lighter place, we see the color white. Okay, all right. Can I say this is because my cones are non-functional क्योंकि cones काम नहीं कर रहे हैं? And then इसके बाद क्या होगा? After this, what happens is basically here, your rod cells get destroyed. What happens here? Rod cells get bleached, and therefore cone cells take up sort of full responsibility, or cone cells perform their function. All right, and this basically is going to take around 5 to 10 minutes. Alright guys. Absolutely. Rod cells are utterly destroyed. Whereas cone cells, are they destroyed or anything like that? क्या cone cells destroy हो रही हैं? नहीं हो रही हैं. Okay, now we also need to understand that when we are in a darker place, ठीक है? Scotopic vision जब हम देख रहे हैं, can I say that my pupils are going to be dilated? जब हम किसी डार्क प्लेस में होते हैं तो हमारी आंखें जो प्यूपिल्स हैं, आयरिस जो है बड़ा सा प्यूपिल कर देती है बिकॉज वी नीड टू टेक इन एज मच लाइट एज पॉसिबल. लाइट एनवायरनमेंट में ऑलरेडी कम है तो एज मच एज पॉसिबल वी नीड टू टेक इन लाइट. कैन आई से दैट scotopic vision, can I say that our pupils are going to be dilated? Don't compare this with your sympathetic nervous system. This is nothing to do with your sympathetic nervous system. Okay, all right, pupils will be dilated. Pupils will be dilated. Okay, and when we move on to cone cell supported vision, photopsin supported vision, जब हम finally light adaptation कर देते हैं, then can I say pupils are constricted? In light vision, pupils will be constricted because now there's too much light coming in and I only need a small sphincter of a space. I need only a small little space for all of the light to be able to come in because there's already adequate light, in fact too much light in my environment. Very very good, very good guys. ठीक है, तो यहाँ पे pupil constrict होंगे. Alright, okay, clear here? Any doubts here? Please ask. Very important for you to understand light adaptation and for you to understand dark adaptation also. Okay. Now most of these functions, can I say, are unconsciously done. We don't give a conscious command to our brain or our, what do I say, to our eyes कि अब ऐसे देखो, अब वैसे देखो. So a lot of times you'll get asked, talk about unconscious light adaptation, unconscious dark adaptation. It's the same thing guys. It's the same thing, कोई difference नहीं है. Okay. Yeah. So these are mostly involuntary functions which are carried out by the body. We do not have to give out voluntary commands to the brain or to our hands or to our eyes. Now do this, now do that. Doesn't go like that. Okay. All right. ठीक है. Let's go. Now let's talk about dark adaptation. Now when we talk about dark adaptation, we are moving from a light place or a place filled with light to a place where there isn't a lot of light. Can I say that? Can I say that? Okay, हम कहाँ से कहाँ जा रहे हैं? Rods are destroyed forever? No, they're resynthesized. We'll see. आप देखो, आप यहाँ देखो क्या हो रहा है. Okay, now we are moving from what place to what place now? We are moving from a bright light environment to a dark environment. अब क्या होगा, अब क्या करेंगे, rods का क्या होगा? देखिए, rod cells have been destroyed earlier. I know that. Yes, when I was moving from a dark place to a bright place, the rod cells were clearly destroyed. But the cone cells are not going to be destroyed because it's going to take a long time for them to be regenerated. कोन्स को रीजेनरेट होने में बहुत टाइम लगेगा एंड एवरी टाइम वी मेक दिस स्विच इट्स नॉट पॉसिबल फॉर अस टू कंसिस्टेंटली डिस्ट्रॉय कोन सेल्स एंड रीजेनरेट देम बट रॉड सेल्स का हम ऐसे ही करते हैं. ठीक है, so let's try to understand what's going to happen. First of all, let's say now everybody I know wants to do this given the pandemic, but imagine that you are outside in a bright light and you suddenly have to go into a theater. Okay, a movie theater, and it's going to be really dark on the inside. Is it? It is going to be, yes, it's going to be dark inside. अब मुझे बताइए, जब हम bright से dark पे move करते हैं, what color are we instantly or initially going to perceive? Cone cells active हैं, याद रखिए, cone cells active हैं. Rod cells अभी destroy हो गए हैं. Immediately when we go from a bright environment to a dark environment, what color are we going to see? We are going to see the color black. Very good. We are going to see the color black. Okay. All right. Now what do we need to do here? The cones need to make space for the rod cells to come to the forefront to be reborn or resynthesized. तो अब हम देखिए यहाँ पे भी लिख लेते हैं. अभी going from high light intensity to low light intensity, high light intensity to low light intensity. But can I say that I'm going from in dark adaptation? I'll write it right here since there is space. Can I say that I'm going from low sensitivity vision to high sensitivity vision? क्योंकि हम photopic से scotopic पे जा रहे हैं. It is high light to low light intensity, but what about the sensitivity? Is that the opposite in case of sensitivity? Sensitivity is going from low to high. Can I say that? Very, very good. Very, very good, guys. This is very, very important for you to understand. Very, very good. Very, very good. Very, very good. All right. Wonderful. Good job. Good job. So basically here can I say that all of the rod cells have to regenerate? Rod cells को तो regenerate करना है ना? Then can I say that it's going to take longer than light adaptation? यहाँ पे 20 to 30 minutes लगते हैं fully adapt करने में. Because all of the rod cells have to be regenerated. It will take longer than light adaptation. It will take 20 to 30 minutes. Even though regeneration of rod cells can be done much faster than cone cells, but because all of the rod cells have to be regenerated here, it takes 20 to 30 minutes. Understanding? Understanding? क्योंकि देखिए cone cells को कभी destroy नहीं किया. So there we cannot say, oh, why is, photopic vision or why is light adaptation taking lesser time? It's just that the cones have to travel to the right parts of the retina, or cones have to take a function where rods are just destroyed. Okay, all right. Cones have to be present over there. That's all. And they need to start functioning. They are never destroyed. But here rod cells are completely destroyed and then they have to be regenerated again. Understanding? So it's the dark adaptation that's going to take longer time when compared to the light adaptation. And by adaptation we mean, this is going to mean the best kind of scotopic vision. मतलब ये highly efficient scotopic vision की बात करता है. Now we know that in a theater when you go in within 1 or 2 minutes you can start seeing things. It's not as though it takes you 30 minutes to see things. We are talking about कि complete function जो night vision में होती है वो कब reach हम कर पाते हैं, वो 20 to 30 minutes के बाद होता है. Okay, all right guys, all right. Please let me know if there's any doubts here. I will be sharing this PDF with you as well on the update section of your course. And this will be included in the 5th unit later in the combined PDF. Okay, all right, wonderful. Okay, let me know if there are any doubts, otherwise we will move on. Okay, great. Bleached. Ma'am, when moving from bright to dark, how rods are bleached before? Huh? What? Huh? Huh? Bright to dark, why will you bleach rods? You have already moved from dark to bright na before. You have moved from dark to bright. That's how the rod cells were bleached. And now coming back, somebody has to recreate them na. Somebody has to synthesize them again. Somebody has to recreate them. When you went see, it is common sense, or it is understood that now that you're moving from a light place to a dark place, you must have moved from a dark place to a light place before. Okay, all right. Ma'am, dark adaptation affects proprioception also. Yes, it does. Makes our senses sharper. Repeat destroying of cones and... No, I never said cones are destroyed. Ekta, did you ever hear me say cones are destroyed? Did I say cones are destroyed? This is a common mistake that learners make. This is a common mistake that students make. Cones are never destroyed. It is the rod cells which are bleached when we move to a bright place, which can be a bright room also. ये देखिए आप, rod cells have been bleached, so obviously we need to recreate them. Cone cells are never destroyed. When the rod cells are destroyed, obviously the cones are going to come to the forefront and function normally, right? Okay, all right. I heard they reposition. So see, the thing is, obviously if there are no rod cells on the retina, they've all been bleached. Who's going to take up function? Cone cells are going to take up function. Cone cells are most likely to be closely present around the fovea. Ma'am, this cycle of vision takes place in daily basis also. Yes, absolutely. Devyani, absolutely. When you go from dark to light places also, it's the same thing. That's why when you wake up in the morning, what do you see? If you suddenly open your eyes, you see white. सुबह में जब आप उठते हैं, ठीक है? हाँ, सुबह में when you wake up, do you not see white when you open your eyes? If it's bright in your room. अगर आपके रूम के पास विंडो है एंड लाइट बहुत सारी आती है अंदर. Ma'am, my comment please. हाँ, I have responded. I have responded. Our proprioception skill remains enacted. Huh? Remains intact. Yes, absolutely. Remains intact. Chaliye. All right. All right. I hope things are clearer now. Chaliye. Come on. Let's go. Let's go. All right. So now that we have understood vision, hopefully we've understood vision. Should we summarize dark adaptation once more? For all of you, should we summarize once more? Chaliye, let's summarize dark adaptation just like we did with light adaptation. Please excuse my bad handwriting. I am getting used to this new tablet. Okay, all right, fine. ठीक है. Now here we are moving from photopic to scotopic vision. Can I say? Okay, हम जा रहे हैं कहाँ से? Photopic vision से scotopic vision पे. Okay, all right, photopic to scotopic vision. Now I know that photopic vision is what? How are the eyes and the pupils going to be here? Pupils constricted थे ना? Constricted pupils is what I had here. And when I talk about scotopic vision, can I say dilated pupils हो जाएंगे? Dilated pupils I will have. Okay, all right. Now what is the light intensity like when I'm moving from photopic to scotopic? Light intensity is high or low, guys? Light intensity, I'm moving from high to low. Light intensity is low. All right. Whereas sensitivity increases. Sensitivity increases because rod cells are more sensitive to light. All right, wonderful. ठीक है. Now when we go from a dark place or a bright place to a dark place, we see the color black. Yes? So when we move from photopic to scotopic vision, we perceive black. All right? ठीक है? That is about it. That is about it. Yes, absolutely. Takes time for rhodopsin to regenerate and therefore takes around 20 to 30 minutes. All right. Okay? ठीक है. ठीक है. Clear now? All right. ठीक है, let's go. Once you understand the base of it, once you understand the logic behind it, it'll get a little easier, it'll get a little simpler. Will I ask you questions on this? Of course I will. Will the NET exam ask you questions on this? Of course they will. Why else would we be doing it? Okay, alright guys, wonderful, wonderful. Chalo, pat on the back for everybody for doing difficult parts on a Saturday. Alright, let's go, let's go. Now we simply talk about audition. Audition is not as complicated. Audition is quite simple actually. यहाँ पे हम देखेंगे कि auditory system के parts क्या हैं, and then we're just going to outline the pathway, and we have two theories of audition. That's all, and then we're done for the day. Wonderful, great. चलिए, all right. Now can anybody tell me the parts of the outer ear जहाँ से sound vibrations actually आती हैं? See, sound comes in terms of frequencies और loudness, है ना? लेकिन हम perceive करते हैं everything as vibrations only. So the frequency of a sound is the pitch, and the loudness of a sound is the amplitude. ठीक है? Sound का loudness जो होता है, this is the amplitude. Okay. And the frequency is the pitch. हम लेकिन सभी चीजें only through vibration understand करते हैं. So we have the outer ear, which is the pinna, and the auditory canal, which is also part of the outer ear. Then we have a membrane between them, which is the tympanic membrane or your ear drum basically. ठीक है? ये आपको ले जाता है middle ear तक, which is your malleus, incus, stapes, the three ossicles, which again further vibrate and take in all of these frequencies and the pitch and the loudness to the inner ear, where we have the eustachian tube, the oval window, and then main important region of our inner ear is the cochlea. Cochlea पे ही transduction होती है. Whereas in the visual system, where does transduction take place? Transduction कहाँ होती है visual system में? In the visual system, it takes place in the photoreceptors. Visual system में photoreceptors में ही transduction होती है. Whereas here transduction takes place at the cochlea at a specific site. So on the cochlea, which is this, a lot of people will say candy, which is the circular structure, ये folded structure है, जहाँ पे आप देख रहे हो, there's a basilar membrane on the cochlea. It's part of the inner ear, ठीक है? And this basilar membrane has an organ of Corti, जहाँ पे ये सारी hair cells हैं. Organ of Corti is present here, where all of the hair cells are. As the sounds come in, they bend and they vibrate. ठीक है, ये bend होती हैं. जितना intense sound होता है उतनी ये hair cells bend होती हैं, and जितना less intense sound होता है उतनी कम vibration and उतना कम bending. ठीक है, and that is how sound is basically carried forward later. ठीक है, that is how absolutely that is how sound is carried forward. Now we know that the auditory pathway can be understood with this mnemonic known as A C S L I M A. Can we go on and write down what all of these A, C, sliма जो हम कहते हैं ये represent क्या करता है? Can we write it down just to sort of freshen up our memory of the auditory pathway? What is the A? What is the A? The A is the auditory nerve. Auditory nerve. Right? Okay. The C is the cochlear nuclei. Okay. S is the superior olivary complex. Superior oli, I will write here. L is the lateral lemniscus. I is, what is I? Okay, alright. I is the inferior colliculus. M is the medial geniculate nucleus of the hypothalamus. And A is lastly the auditory cortex. Auditory cortex. ठीक है. Okay. Alright. Very good. Very good guys. Very good. Okay. That means we still remember. Ah, very good, very good. Now let's understand characteristics of sound before we move on. Okay, let's understand characteristics of sound before we move on. The loudness is actually how large the wave sound wave is. ठीक है, और इसको हम perceive करते हैं, ये इसको this is basically the amplitude of the sound wave which we perceive as loudness, and this is understood in terms of decibel, dB, right? The least amount required for us to perceive is 0 decibel, है ना? Okay, so what is this basically? This is the length or how large a wave is, which is nothing but the amplitude. And the amplitude we understand as loudness. इस पे भी questions आते हैं. Amplitude is understood as loudness, whereas the pitch की sound कितना repeat होता है. See, a lion's roar is a long sound. Lion की roar जो होती है वो एक sound होता है ना, continuous sound. Can I say that? So that is a loud sound with a high amplitude. Whereas if you talk about a pitch, चिड़िया या sparrow का जो sound होता है, again and again and again and again, छोटे 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 sounds repeated again and again. This is typically, that is a high pitch. Frequency, cycles per second measured in terms of hertz and are perceptible. Sort of limit is from 20 to 20,000. Is the sounds that we perceive. Hanji, absolutely. So we must understand that frequency is nothing but the pitch. हम perceive करते हैं frequency को as pitch and हम perceive करते हैं amplitude को as loudness. And lastly, quality is basically timbre. This is basically saying that, see, the sound waves which Mozart produces as music, you don't understand them. You don't understand them as the sound waves, but you understand it as quality of the medley or the melody, right? How is it nice? Is it soothing? Does it make you happy? Is it good quality piano? Is it not? If the opera singer is singing, is her voice breaking in between or not? All of that is timbre, and all of that is simply the quality of the music that you are listening to. Okay, all right, fine. All right, guys, is this clear? Once this is clear, please let me know. We'll move on to the two different theories of sound. That's all. That's all. Chak Puja से क्या चाहिए आपको? Ma'am, how much do we hear without damaging our ears? Around 75, 85 decibel, I think, in extreme cases. Higher than that is harmful. I remember around 65, 75, something like that. Clear, ma'am. Clear, ma'am. Thank you, guys. Okay, let's go. Let's go then. Okay. All right. All right. All right. Chaliye. Now we have two theories of hearing. Okay, we have Hermann von Helmholtz and then we have George von Békessy, who basically spoke about the same thing, different points, same theory. Then we also have frequency theory of hearing. ठीक है, इसके बाद की. First, let's talk about what is happening here with the place theory of learning. Okay, so earlier Hermann von Helmholtz said that a certain kind of sound, high frequency, low frequency sound, हमें अपने कोक्लियर मेम्ब्रेन पे अलग अलग जगह पे स्टिमुलेट करेगा. Okay, that's basically it. So first of all, what did he say? He said that different pitches, because different sound waves trigger different places along the cochlear's basilar membrane. Makes sense? That there's a certain place on the cochlea which responds to a particular kind of a frequency. I can simply sum it up like that. ठीक है? Okay. That a particular place on the basilar membrane is responsible for understanding, for perceiving different different frequencies or particular specific frequencies. Responsible for That's it. Correct, Prince. Correct. Okay. All right. Fine. Now let's try to understand. First, he said, ki, okay, basilar membrane. Then George von Becasey gave us specific places. He said कि जो आपके ये base है ना, membrane की, high frequency sounds can I say are heard here. आप देखो, आप I will just say कि आप सोचने की कोशिश करो या imagine करो that high frequency sound. Do I need a lot of effort to understand it? A lot of vibrations. So must I send it to the apex of the basilar membrane? मतलब basilar membrane के बिल्कुल end तक हमें ये send करना पड़ेगा, या base पे ही हम understand कर पाएंगे high frequency अगर है. So if I have high frequency auditory data, this is likely to be understood right at the base of the cochlear membrane. Okay, तो ये आपको पूछेंगे high frequency waves are understood where or are perceived where or are taken in by what part of the cochlea. Easy to understand, है ना? Absolutely, absolutely. Base is for the higher frequencies, easy for us to understand. उसके बाद जो low frequencies होती हैं, बिल्कुल low frequency, we will need to send that data to the apex, which are supposed to be highly sophisticated in functioning. Understanding. Now we will need to send the low frequencies to the apex, which is the highly or the innermost part, you can say, of the cochlea, right? We are assuming that this is highly sophisticated in function, and therefore we must send the low frequency sounds right till there so that they can be understood. All right. Okay, fine. Please let me know if we are clear here. That is our place theory of hearing. That is it, and that is our place theory of hearing. Okay, हाँ जी. तो अगर आपको कहेंगे who said base and apex and all that, it was George von Becasey. हाँ, whereas Hermann von Helmholtz first spoke about the fact that different places on the cochlear membrane must be perceived in different places. Must be perceiving different frequencies of sound. Okay, all right. चलिए, let's go. Fine. Now another theory of hearing is a frequency theory. This says let it go. It's not about the place. पूरा आपका cochlear membrane vibrate करता है, ठीक है? Frequency theory says कि पूरा cochlear membrane will vibrate when a sound comes in. But it will vibrate only as much as the intensity of the sound coming in. Okay? What was I saying now? So we are saying that all of the auditory membrane, all of the cochlear membrane will vibrate. Okay, all of it. But depending on what? Depending on the intensity of the sound. Intensity of sound. मतलब अगर low intensity या low frequency sound है, how much will the basilar membrane or how much will the cochlea vibrate? More or little? More or little, it will vibrate a little bit. Okay, so let's say if the sound wave has a frequency of 100 waves per second, 100 pulses per second travel up the auditory nerve. So here it is proposed as if exactly the amount of stimulation we are receiving on the outside, just like graded potentials. Graded potentials में हम क्या कहते हैं, जितनी stimulation आ रही है उतनी हम भी action करते हैं. So here exactly that is what is being said, where 100 frequency or 100 hertz travel up, and therefore exactly 100 pulses per second will be conducted by who? By the hair cells in the organ of Cornea of the cochlear membrane. Okay, all right, ठीक है. तो more frequency, more vibration, less frequency, less vibration, low pitch, low vibration, high pitch, high audition or high amplitude, high vibration. That's all. So हमारा brain जो understand करता है sound, it understands pitch and amplitude and all of that together, not separately. So you don't need to worry about it. So since one neuron cannot fire 100 waves per second, see now we are saying that when 100, a frequency of 100 of a sound is brought to us, ठीक है, sound जिसकी frequency 100 है वो हमारे पास आता है, okay, then 100 pulses per second will have to travel. Then can I say that one neuron will fire these 100 pulses per second? 100 impulses क्या एक न्यूरॉन से आ सकते हैं in a second? Think about it, guys. Can it? Can they come from one single neuron in the pathway, in the auditory pathway, after the auditory nerve basically? कोक्लिया के बाद जो आती है ऑडिटरी नर्व आपकी, क्या वो एक न्यूरॉन 100 एक्शन पोटेंशियल्स कर पाएगा एक सेकंड में? Highly unlikely. Highly unlikely. So what we do basically is we have a volley of cells. We have a volley of nerve cells. आपको पता है how it's done in army and how it's done in fighting? That one round of people will go will defend for 1 hour, 2 hours, and then they will change it with another round. Battalions, you see. So think of these cells just as that battalion. ठीक है, तो ये वॉलीज क्रिएट होती हैं. तो इफ समबडी आस्क्स यू वॉली थ्योरी ऑफ हियरिंग, इट इज नथिंग बट द फ्रीक्वेंसी थ्योरी ऑफ हियरिंग. सेम है, ये सेम है. दिस टर्म इज क्वाइट पॉपुलर एंड वी यूज इट. वॉली इज जस्ट दैट 100 cells may line up together or 30 cells may line up together and fire. Fire. What action potentials and impulses? Okay, after that they exchange places with another 30, 50, whatever neurons, and they fire. Okay, so action basically is taken up by volleys of cells, just like soldiers, so that we can process information, auditory information efficiently without any delay. Because अगर आप सोचें auditory information कितनी quickly आती है आपके पास, and उसको integrate करना, उसको consistently समझना, we think it's no big deal, but it is a little bit of a big deal. If you think about it, it is a bit of a big deal. Only 70 what? A decibel is very, very loud. 4 decibel is double of 3 decibel. 10 decibel is almost double of 9 decibel. Decibel is each basically quantity is raised to a power, and then the next quantity comes in. उसकी measurement ऐसे normal नहीं है. What is the maximum capacity, ma'am? That I have not measured and we don't need to know. So basically here, hypothetically, one neuron cannot fire at the same time within 1 second. 100 action potentials. एक neuron नहीं कर सकता वो. Right? So here we may have a frequency of 1000 of 10,000. Do you think one neuron then will be capable? Do you think one neuron will be capable of firing 10,000, what do I say? 10,000 impulses? Okay, all right. All right. All right. ठीक है. So the volleys take care of it. The volleys together combine and they form teams and they are able to carry out whether it's 100 impulses, 1,000, 2,000, 3,000 like that. Depending on the waves that are incoming, depending on the frequency of the sound waves that are incoming. Okay, now what have we decided here or what have we spoken here? Basilar membrane कहाँ पे present है? Somebody is asking me to explain the second paragraph. Basilar membrane, can I say, is on the cochlea only? Yes? Yes? So what did we discuss in the beginning? That the whole basilar membrane vibrates. At any frequency, the whole basilar membrane vibrates. अब देखो, even 25 hertz पे, just the amount it is vibrating differs. And at the same time, it will trigger. The moment that this vibrates, is it not triggering neural impulses to the brain also? Saying कि देखो, आपको कोई पूछ रहा है, what are you doing tomorrow? Somebody is asking you, what is the name of the first prime minister, first president, this and that and all that, and you have to answer. तो वो तो brain पे जाने हैं ना impulses. At the same rate as a sound wave. जितना जैसे sound wave process होती है, उसी rate पे आपके brain तक भी information जाती है. In order of considering how we need to respond. We need to respond also to auditory waves. Hearing is not just for fun. Hearing is also for responding. है ना? Okay, all right. Like that. All right, guys. I think that is about it. If there are no further doubts, we are actually done. If you guys have any doubts, you can ask, but except for that, we're pretty much done here. All right, so it was great learning with all of you today. Unless there are any doubts, if there are any doubts, please ask. I hope you learned something new today. I had a lot of fun talking to all of you. You know where to find me on Unacademy. All you have to do is there will be classes, there will be links below, there will be links to my profile as well. If you do want to access the free classes, you can use the code Hafsa Live. Now, I hope you have a great rest of the day. What should you do for the rest of the day? Eat, live, laugh, spend, have the time of your life. Happy Saturday to everybody. If you want to join the group is Net with Hafsa. It is my Telegram group affiliated with my Unacademy classes. Okay, it's Net with Hafsa. I think I've written the spelling wrong here. I will go ahead and correct it. Alright guys, if there are no further doubts, we will end the session here. Thank you so much for learning with me. I hope you liked the class. If you did like the class, please make sure to give it a thumbs up. Okay, alright. Pitch is the perception of frequency. Frequency जैसे चिड़िया छोटे sounds करती है. Okay, amplitude is the loudness. How lions roar happens, or when people scream and it's a single scream. Amplitude is basically the loudness of the sound. Loudness we understand. ठीक है, we understand loudness. Loudness क्या represent करता है? It represents the length of the wave. It represents the amplitude. You guys have a great day as well. Like I said, if you like the class, please make sure to give it a thumbs up. That is it from me. I will be ending the class here. Bye guys. Have a great day.